love the Silicon Brighton jingle. Hi and welcome everybody to Brighton Pi. It is absolutely lovely to see everyone. I know the nights are turning darker and colder, and I saw some bins flying down the street a couple of days ago, so I know it's a bit treacherous getting in, but thankfully today is a bit drier and we can actually make our way in. Hi to everyone who's joining us online, but thank you the rest of us who are here today. So we're here tonight for Brighton Pi, and we've got a few little things, just a standard that we always talk about. We are live streaming, so there's going to be some promotional stuff online. If you do not want to be on camera, hide your face or tell us and we'll just put a big snake over your face or something. Any questions you've got tonight, if you could just wait to the end so our speakers, Stefan and me, can just get our talk over with, and then you can ask any questions. I'm Laura and I'm from Data Cove, and if you look down at the back, Sophie, our lovely Data Cove colleague as well, is there, and you've been signed in with her. So yeah, we are, and I'm sure you all know, oh, not yet. If you want to hashtag it, we do have a hashtag, so you can post online, share your experience. There you see some friendly faces in that photo, so hashtag Brighton Pi. And here's what we're going to be up to today. Ooh, apparently, Stefan, you're not starting to 7. That's a lot of talking from me. I might not talk that long, but who knows? We'll see. Yeah, so we work at Data Cove. And Data Cove are R, Python, and Shiny experts. And we mainly work with 3 areas. We do customer analytics, letting you find out who that most valuable customer is. We do some marketing analytics, helping you maximize that campaign and that ROI. You know, just because when you code, you help people make things go faster. So we do a lot of process automations as well. If you would like to use our services, please do come and chat to us today. We are obviously massively big into community as well, because that's what makes the world go round. And these are the communities that we run. We've got a few extra actually as well, but these are the ones that are coming up next. So if you happen to be in Bristol or Manchester, those are the next dates for those. But for us, you will see we're having a special merged mashup party between Brighton R and Brighton Pi on Thursday the 20th of November. So we are back again next month for a Christmas R versus Python, possibly. We've just had an amazing idea. We think we might go a head-to-head quiz. I think that would be cool. So please come, be in the Python team, and kick the asses off the R people, because that's what we need to show them who's boss. I know there's some people in the room who are R people. Not saying anything. But yeah, so that might be cool. No guarantee. It's just me, Vicky, and Sophie have made that decision tonight. We'll have to obviously check with Jeremy, but I'm sure he'd be fine with it. But yeah, please do join us again at our next event. And we've also got London R at the end of the month. We could not be here today without the wonderful support and help and basically everything done by Cameron from Silicon Brighton. We've got Andy from the Eagle Labs, and our sponsors tonight is Jumping Rivers, who are our lovely friends up north in Newcastle, who do wonderful consultants as well. So Cam is just taking a little break, so I'm going to be my Silicon Brighton face. Silicon Brighton are the hosts of Brighton and Hove Tech Show. Tech sector, they run loads of things. Here's just some of the groups that they run. So we've got quite a long list. You can obviously see our little snake over there, but there's lots of stuff going on. And these are just fantastic meetups. So do, if you're interested in anything else here, please have a look around and see what you would like to join. And Silicon Brighton would like to thank a lot of their supporters. You probably see a few little things on our sheet here, but yeah, they couldn't do it without the support that they get. They've also got James Chase, who is their major sponsor, along with Plus Accounting Chartered Accountants, and More Law, and Alarity, right. And there we go. Okay, if you're interested and want to stay up to date with all the events that Silicon Brighton do, they have a Slack channel. Brighton Pi has its own channel within this channel, so if you want to keep up to date, although I am not very good at Slack, so I keep on forgetting to post, and I probably should have posted today going, well, we've got a meetup, but you've all turned up, so that's okay. But yeah, I'll put any important information on here, and Silicon Brighton are always giving us lots of lovely updates as well. Right, see, I wasn't going to talk for half an hour. Without further ado, I'm going to welcome Stefan up to the stage here. So thank you, Stefan.
Thanks, Laura. I've actually got my own mic, I think.
Yeah. Want me to do anything?
Swapping over to this one. Nice. Does it have a in Teams?
Yeah. Oh.
Don't download it. What if I do not that one, but
You can just push next. Probably just.
we're being super professional today. Should just download it.
Oh, is it because it's not downloaded? Oh, I don't know, yeah, let's give it a go on that. Sorry, everyone. Anyone have any jokes? No.
What did the 0 say to the 8?
Something about 7 and 9.
Nice spelt.
No, that was good.
I'm trying to open it in a different software.
It's just being slow.
Yeah.
I mean, we could.
I'm trying to see.
Yeah.
Oh, this is
This
right.
will have
Has it got?
present. Yes.
There you go, dude.
Success.
Sweet.
Actually, this is not a bad introduction because I'm going to talk about work that I did during my PhD in Durham. And the whole thing was trying to make, I'm sure if you've used Python, there's the first time you try it and it doesn't work. And the many iterations of making it work. So this is the summary of using PyQt, which is still a current application framework. But I was doing this 6 years ago, and there are also other frameworks which have come since then. Before that, because it's more fun if we interact, I'm running a little local network. It is a router that I took from my parents, which means that it'll log you in if you use the QR code and if you want to join in. But then you have to go to the little dots and say, use the network as is. Don't change the admin settings on the router. And there's a little quiz, and there's also a little graph of a temperature sensor, which is this little thermistor here. I'm not mixing all of your talks. It's just a brief breadboard. It'll become more relevant later in the talk, but the kind of things that we were doing is interfacing sensors and the inputs from those in an experimental control software. I don't know if you have a physics background, but you want to correlate all of your variables. So having those time stamped was part of what we were doing. And this is just like a little dummy example for you to see. I presume you found the link to the URL if you needed it. So yeah, as I mentioned, I'm going to talk about PyQt, but as a dutiful Python user, I looked up all of the equivalents that I could have used if they'd been around at the time and doing it. So, and a lot of the time now, people are actually using web interfaces. Maybe you've had experience with Dash and Django and Flask that make it super easy to make a little pop-up web page. If you just have a little, like you just want a button, tkinter is an inbuilt default for Python. Kivy is one that I've only just heard of, and apparently is quite good for interoperability. And if you're making mobile apps, Python can do that 2 as well now. And I include matplotlib because as a physics person, we plot a lot of graphs. Matplotlib is very familiar, I'm sure, to lots of people. And it can be interactive. So we'll see an example of it, even though it's not recommended for bigger applications. But in that case, you would be using PyQt instead. I figured I would put in little examples of each of these just as a comparison. How to make a button in Flask. You have to host a whole web server so that someone can see it. And that framework is useful for if you need people remotely to access what you're doing. But the reason we didn't use that in our lab is we're concerned with a lot of data transfer at speed and seeing the results in real time. So network latencies can be a disadvantage. tkinter, you might have tried to use and then moved away from, because if you get beyond a little example like this, is frustrating. It's easy to pick up, but not recommended for bigger apps. And Kivy, I put in because I think if I was redoing this, I would have gone back and tried. It looks like a fairly modern, it's still under development, it's open source, and you can see there how quick it is to create a simple UI. And I'm told that it also scales well for more complicated applications. And I have actually used matplotlib occasionally because you've already made, say, your graph and showing your results, your data. You might turn it into a GIF or an animation that is there, and it doesn't take many changes to your code to just output a GIF instead of a image. And in particular, I've found it quite helpful now. They have a get input, where if you just want a couple of points and to I know this is my image and that's the feature I'm trying to make my segmentation find, and it's just there. You can use this to click on the point and return it. But here is our equivalent example with PyQt. So it is very much object-oriented. We need an application which is running our event loop and hosting the whole app. It takes in your system arguments, but you would usually just leave that rather than passing any arguments directly to it. And you can select from a very wide range of window layouts. Different types of widgets would be your buttons and drop-down menus and those kind of things. And this little clicked.connect is our signal slot architecture. But before I get into that, here's a summary of some the table of which you should use in which situation of those apps, in case you're considering choosing between them. So I do want to cover the kind of what Qt is good at, what it's been designed to do. You can create an app which has cross-platform capabilities in Linux, Windows, or Apple. All of the types of widgets that you would use in your application, buttons, graphs, and that kind of thing, are available for you to choose from. And one of the big things in an application is keeping your UI responsive while you're doing the real work. So Qt has an event loop which does that. It doesn't just freeze up the UI with polling a loop. It is event-based. And the signal slot architecture, we'll explain more in a minute, is allowing us to respond to those events. I have found Qt has an open source GPL license, which if you want to use then means you have to also make your code open source and publish it. Or if you are working at a company, then you can buy a commercial license to not publish all of your code. And before we get too much into written objects and codes, if you're making lots of buttons, you can copy and paste, or whatever chatbot you're using now to write your list of widgets. But they also have a visual GUI that you can use to click and drag and see your UI assemble as you make it. So I mentioned the event loop already. The main part that I want to pull out here is instead of polling, each interaction, so a mouse click or even the mouse changing position across the screen is recorded as an event. You connect signals to those events, or you can even create your own events as a timer object, and an event will occur at a set delay. And then this loop, which runs in the main thread, can send functions. So the event has some data associated with it, which is transferred to some slot. The slot just being a function. This hopefully isn't too oversimplified, but just to get the signal is data and slots are functions. Under the hood, that is, you can quite easily use multi-threading and asynchronous non-blocking execution with this, just by having your slot running in a separate thread. But that would be async. So since we're not async, by default, these are running in the same thread. And so you do have to watch out if you're doing if your function is processing for a while, that will block the main thread and your UI freezes while it's executing. And handily, all of the kind of buttons and widgets that you would add come with the signals that you would expect, like I've been clicked on or I've finished processing the thread. So here's an example of what that looks like. If you have a button and someone clicks the button, you send the signal of the button being clicked to a function, and then it records an action. It's more useful to create your own signals and slots. So in this case, it has to be object-oriented so that this signal can be established before runtime, because signals are hard-typed. It's very useful, actually. I guess people complain about Python being soft-typed sometimes. These signals might have many connections, but the data that transfer, so whatever the signal emits is a string type, will be sent as an argument to the function that you connect it to. Yeah, and in fact, many times you'd be connecting. So in my example, we were building an experiment which controls atoms, actually. This is a picture of a lot of lenses and some acousto-optic modulators. So you send an RF signal through some glass and it deflects light. The paths here that the light is going down have lasers at one end, and an optical fiber at the other, which sends the light down vacuum so that you can trap single atoms. And it's called a tweezer because it's like you're picking up an atom between the tweezers. So in this experiment, the main data that we're processing is images from a camera with very high gain, so that it records the light that's emitted by an atom, which is only a few photons. But the challenge of the experiment is that the atom's only going to stay around for a few hundred milliseconds, or by the end we got it up to a few seconds, but that's the challenge of extending the lifetime you can hold the atom for. And this is quantum physics, so each interaction, each measurement collapses the state, and then it's gone. So if you want to learn about the probabilities, the statistics involved, you have to repeat the experiment over and over again, and then converge towards the probability. So we want our experiment to run as fast as possible to record these images and then build up the statistics into histograms. So in each image, we're setting an ROI, not a return on investment, a region of interest, and counting whether it was dark or whether it was signal, and set an adaptive threshold between them. Here it's nice. Often the signal emitted by the atom wouldn't be that clean, and you have to accept that there's some error in the probability, and then build up. So this is one histogram, which will tell us in this experiment there was a 50% probability of keeping the atom after we acted on it. And then you would change some variable and repeat the experiment and measure again. To make all of that work, we had I mentioned some RF synthesizers. Those take waveforms in, so you have to control the frequency and the power. The lasers also have not just their own power and frequency controllers, but as hard as you try, it's very sensitive to temperature. So we are monitoring the humidity and we did have aircon controlling the temperature, but we're also measuring how much the temperature varies within that, so that we can correlate changes in the laser's power after it's been stabilized to fluctuations in the temperature. When we're moving atoms around, so you change the frequency of the laser and you can move one atom next to another and make them interact. Those time signals have to be synchronized with the running of the experiment. So we actually had an FPGA, which was doing those. We called it Dexter. This is just an FPGA is the compiled code on a specialized board, which is connected to a separate computer, which creates these waveforms, and the clock rate is synchronized so that we know the events happen in one experiment to microsecond stability. I didn't mention the magnets, but those are also involved with cooling atoms down. With the magnets and the other kinds of electromagnetic radiation that we put onto the atoms, we have other generators which control their frequencies. We have the camera, which is imaging the atoms and controlling the frequencies and the powers of the directions of several lasers in this case. Atoms react differently to different colors of light, so we needed several different colors of light in order to control them precisely. And all of these are coming under one app through various connections, so where we need fast data transfer, take it cable-based by USB or transistor logic, and where the experimental timing, that synchronization isn't as important. We just record it on some device, a digital acquisition device, and then later log the monitored events and the experimental data to a database. So there are several of those hardware devices, and our app recording all of this data needs to be happening in sequence. In particular, this image analysis, if you lag behind the scale of our experiment's repetition rate, which is there's an image coming every 100 milliseconds, then you'll lose data. So it's important that that section of the program running the image analysis is prioritized. And it's also frustrating for the user, so having created software that other people use. If you prioritize the image analysis and the user interface phrases, they're likely to click buttons until it crashes. So we also want to keep the interface running, which works for us in a couple of threads. So the main thread is where we have all of our interface. It's got some buttons. Here I'm going to build up some histograms of whether the atom was there at the start of the experiment, whether the atom was there at the end of the experiment. And the user can choose like where in that image the atom is, and various kind of options. But in the background, we have to be receiving the images from the camera. So there's a thread which is triggering on the event of the camera's SDK releasing an image. We're going to control the RF synthesizers, mainly being their set frequencies. So this isn't, I mentioned that the FPGA controls any time-sensitive outputs, but between experiments we'll be changing settings like the central frequency, and so communicating with those modules over a TCP server, and kind of data logging. And I don't know if I'm drilling a point over and over again, but just to see the flow of that histogram generation, the user's going to set up an experiment. The app queues it up on the FPGA. The FPGA does all of the time-sensitive information, triggering the movement of the lasers, and tells the camera when to start its integration time, where it accrues signal on the camera. The camera SDK sends an array of the image back to the Python app that we're doing, and then we're triggering the histogram to be built up on each of those events. So this runs around at least several hundred times to build up a histogram. And that's happening at several times a second. And then once you've got one histogram, we're going to repeat the whole process to get us plots like these, where it was working nicely. So in this case, our experiment is determining at what hold time of the atom we can recapture it. So start with the laser on, turn it off. If you've turned it off for too long, the atom's flown away. If you turn it off for a short amount of time, it hasn't barely moved, and so you can recapture it. And the temperature of the atom, which is measured with this recapture probability, is going to increase with the time that the atom is left in the trap. So the light from the laser is warming up the atom over time. But it's also dependent on how stable our system is. So when it's working well and our temperature and humidity monitoring showing that the lab is within sensible bounds, then this temperature is lower. And so we can use this as like a quick measurement of whether the experiment's working or not. Yes, I think this is this is what it looks like for one user. You can see he's got a box of the region of interest where he's going to sum the signal over, and it's not where the atoms are. It's actually because we have an array. So there's, if you did what I was describing with just one atom in one trap, you have to build up statistics 8 times as long as if you had 8 traps all in a row. So this kind of allowed us to speed up the experimental process. And then you just have to make sure that your processing isn't held back by the fact that now there are 8 regions of interest, each with their own histogram and image being processed, not quite asynchronously, but fast enough that the data transfer doesn't hold back the experimental process. And actually, the thing we found was that most of the delay is just in displaying images or updating an interface. So if you want to speed things up, just cut out the image temporarily. That is actually the summary. I wasn't watching the time. I probably powered through it. Which means that if there were any questions, we could ask questions.
Thank you so much. That was amazing, incredible. I'm a little bit blown away. That seems like a really cool thing to do. There was a question. Where was it? There we go. Thank you.
Ooh, microphone. Thank you. I wanted to ask you about the camera you use. What kind of camera can capture the atom in it? Like, what's the resolution of it, or like what zoom was involved?
You can see it's called an EMCCD here. So CCD is a charge-coupled device where the electric signal on the semiconductor is converted into a digital signal of how much light there was. The EM is electron multiplying, so they have somewhere where that a bit like a capacitor will accrue charge. There's a gain medium in the camera where a few electrons, so the photon hits a semiconductor and gives off a couple of electrons, and that gain is multiplied through a voltage medium, and then you can record a measurable analog signal which is converted to digital. So that's the sensitivity to low signals, and you have to cool down the semiconductor because there's thermal noise. If you have a warm electronics, then you generate electrons just from the heat in it. So it's at -2 and -150 degrees. And how you zoom into an atom is actually just the lenses that you have in front of it. So if you focus down, you have a wide beam of light and put a lens with a very short focal length. Then we narrow down the spot to about 1 micron in size. And when it's focused to that smaller region, then you can trap an atom inside it. Or image the atom the reverse way.
Okay. I barely understand, but thank you.
It does sound a bit complicated, but yeah, amazing.
Not quite Python, but...
Well, there's hi in there, I can see. Any other questions for us? Oh, yes.
It's probably more physics and electronics based or electrical, but when you said voltage medium, is that like something that is there to just get excited, produce a voltage? Like, it kind of reminds me of like valve electronics, that you put signal in, it moves it a little bit, gets excited, then goes massive. Is that sort of it, or?
Yes, I can't remember exactly the material, but it won't be copper, but something that's good at conducting. So if you apply you have a potential difference across it, and then you receive a small current, that current can, I mean, it can't be a wire because then the current is proportional to the, yeah, that's the kind of gist of it.
Okay, cool. So kind of like an amplifier, but a little bit more just purely not semiconductor based.
Yes, yeah.
Okay, cool. Sweet.
Amazing. Any other questions? I think you've blown everyone's mind. Excellent. Nigel's got one for you.
Yeah, mind blown. Not really formulated the question properly, but what's the next improvement? If you got an order of magnitude of accuracy or speed or something, and what benefits would that bring?
Yes, the aim was always to bring these timescales down, because if you have to repeat the experiment 100 times to build up statistics, that's limited by like physical quantities like the probability. There's like a limit on how much you can reduce the uncertainty with a number of iterations. So only want to, I mean, it's also the challenge of quantum computing, and a lot of these things now is scaling up. In order to scale up, you also have to have these run faster. And parts of that would be this time scale is just waiting for an atom to appear in the trap. So there's a kind of physical side to that. But then part we were considering here is your software also has to be able to keep up with that. Did that answer the question? Is there a follow-up?
Yeah, and what benefit would that bring if you suddenly had a revolution in coding or tech or whatever, and it was 100 or 1,000 times faster or more accurate? What would you be able to do as a result?
Right. So probably the way you can tell I'm not in this subject area anymore is I haven't mentioned the application. So we were building arrays of optical tweezers so that we could create arrays of molecules. And those molecules are a good system for either quantum simulator or quantum computing. The like interactions between them can give you the gates, which are quantum gates, or the states of the molecule can be your qubits. So by making all of it run fast enough that the timescales are within the lifetime of your, if you can only hold your atom for so long, and that's encoding your bits for your logic gates, you need to do as many operations on it as you can before it disappears. So we need the experiment to run fast so that you can actually use it as a quantum computer or a quantum simulator.
Wow, yeah. This is. Any other questions? I've got one. I'm going to try. It might not be the right question, but do these tiny little atoms behave differently after they've been viewed? Is that an issue, or is that?
Yes.
Do you have to take that into account in your experiment?
When you image it, that is the measurement that collapses a waveform. So if you create a superposition state, is the kind of quantum process that makes quantum computers more attractive than classical computers. And that superposition might be, I've got two atoms next to each other, close enough that they're interacting, and they might swap to be in the same position, and then I don't know whether they're separate, both in either of the traps, or they might have disappeared. And as soon as I image them, that state of superposition is collapsed, and I know there's one in this trap. And then afterwards, there's only one. You've like formed that. But before you've imaged it, the state can interfere, so it can kind of be both at the same time. But that like measurement of defining the state is when we image them.
Amazing. Thank you so much to Stefan. We'll have a short little comfort break now, and then we'll come back and, because you've been talking about UI and stuff, I'm going to share some code. Why not? For giggles. But yeah, 5 minutes comfort break. Right. So next, I'm going to have a little chat, because you just can't stop me from talking, basically. I was just going to do some highlights from EARL, but because we do have a little bit of extra time, I'm actually going to share my talk from EARL, or at least parts of it. So if you were not with us at EARL, you're going to have a little sneak peek of what I presented. There's a picture of me up at EARL. Ooh. Thank you. So I made a dashboard out of Shiny. And for those of you that don't know, Shiny is just like a interactive visual dashboard tool, like Quarto, like Streamlit. It's just Shiny. It's built by Posit, who do the R code, and it originally was for R coders. And then the last few years, they've decided to make Shiny for Python. And I was like, oh, we'll give that a go. And the documentation is really nice. It's actually very lovely. So I decided I would, do a little dashboard. So I've called this Duck Dashboard. There's a whole story. You don't need to worry about why. But obviously, we've got ducks in the room. So our Data Cove ducks is kind of what we were looking at here. So this is lots of duck information. Now, because I do work at a company that does a lot of R as well, I obviously had to add in some hexes. So I'm going to show you the code to make some hexes in a Shiny app using Python. And in case you've never seen it before, Shiny is completely interactive, so you can change all of these things. There we go, and it changes for you. You can change the scatter as well. You can filter. And it just kind of picks everything up. So it's really nice because the users can then actually interact with your data in a way that, however they need. So it's always quite lovely. So I'm going to share for you in a second some code for that, but also because I was working with a client the previous year that had asked, could you put AI chat, an AI assistant, inside your Shiny? And I was like, oh, I think so. So I thought, yeah, let's give it a go. Now, when I built this last year, it actually wasn't on the Python for Shiny documentation, but it is now, so it's even easier to do now. But so I'm going to show you the easy version. So here we go, we've got the helpful duck. Oh, I haven't tested this live, so let's see. I've actually created some quick filter buttons, quick questions. So my users were people who were not within data teams, they were within marketing teams. So they maybe didn't know what questions to ask. Who am I talking about? They knew exactly what questions to ask. But I made sure that they were really quick. They didn't even have to type them. So what are the top 5 KPIs? Oh, it works, yay. So my little helpful duck, I'm wondering if Jeremy just switched off. We're like, you've done your talk, stop paying for that. No, but he hasn't, that's great. We'll have to remind him, Sophie. So yeah, there's my top 5 KPIs, that's quite good. What about some anomalies? Yeah, I can't be bothered looking at the data myself. It's not as if that's my day job. Let's get chat to waddle through the data swamp. There you go, it's given us some anomalies. We could also just do a random duck fact because, who doesn't love a random duck fact? Did you know that ducks have a special way of staying warm in cold water? Their feet have a unique heat exchange system that keeps them toasty without losing too much heat, like built-in thermal socks. Quacktastic. Love that. So yeah, I'm going to share with you the code to be able to do this as well. Does anyone have a question for the helpful duck? Oh, go on then.
Did you have integrated RAG into it? RAG.
Oh, did you RAG? No, I did not. But let's say, are you... I was going to ask the duck. What would you like to ask the duck? I didn't use RAGs, no. I used... I'm going to show you how I built it in a second, but have you got a question for the duck? Go on. We have a question at the back here. Oh, I'm going to do that later. What's the question for the duck? Come on, let's give the duck a question. Oh, brilliant. Yeah. What question should, this is weird typing with one hand on a microphone, should I ask you about the data? Come on, let's, yeah, why not? I'm not steering it at all. Oh, sorry, a bit loud. Fishing for questions. Okay, even it called me out. I totally agree. I'll take that back. What's the quacking deal with leg-wing ratio? What type of duck is the most common in the pond? Now that's quite a good typical data question, isn't it? And do the different types of ducks compare? How do they compare in terms of their wing and leg lengths? Go on, make a splash with your curiosity. But yes, fishing for questions. Okay, anyway, it works. It's brilliant. Yes, one more?
What name would it like to have?
Oh, now hold on, because this isn't a next year competition. So next year we're going to have a name the duck, the best duck is possibly, I don't know, Jeremy's not here. We might win an EARL ticket. That's not confirmed. Don't tell anybody. Okay, it's not as if we're live on the internet at all. What is your name? It might just be called the helpful duck. I don't know. Let's see what it thinks it's called. Oh, I'm Quacky. Oh. All right, Quacky. I didn't realise you had a name. There you go. It thinks it's Quacky. Keep that in mind, but there is a competition next year, probably. Anyway, so that's Shiny. It's really lovely. It's really advanced. You can put it online. You can, make it logins and authenticate and things like that. So you can create it. We create it for our clients who then go in, log in and sign in, and they can see what their heart desires, of course, and interact with it and play around with the data themselves. So they don't have to kind of wait for us to give a presentation, and they can explore their own data. So that's quite lovely. But if we pop back to here, so what is Shiny? Shiny turns your data science scripts into interactive web apps, and loads of people use it. I'll skip through these quite quickly though, so don't worry. Oh no! Is it back? Is it back? Ah.
We were seeing. There were no notes. Just doing it.
I'm totally just doing it all from my head. I don't need the notes.
Because we're seeing this. Sorry, everyone.
That's okay. Another joke. Don't tell another joke. Oh. The people online didn't hear my joke earlier.
Did they not?
Should I say it again? Okay, same joke. Everyone has to laugh as if you haven't heard this before. What did the 0 say to the 8? I haven't. You can't laugh before the punchline. Nice belt. Ah.
Sorry.
That's okay. I think.
Oh, I don't know how to stop it doing this.
Okay, I think I do. It's that button there.
Is it that one?
Yeah.
Sweet.
I'm hoping. Did that work?
Yeah, that's good.
Cool. Okay. Let's see what else we've got. So in Shiny, you kind of have to write a few different scripts. You can write it as one in Shiny for Python, but actually, to keep it very similar to the R kind of style, I've preferred to keep it separate. So you have your UI, which is your user interface, which is what the users use. Keep going. Okay. You have the server, which you go back in, and you do all your code, your Python calculations and whatever else, and then you make it pretty. You have your styles, and that's your bit of your CSS or HTML. If your user interacts with it, it goes into the server, it does the calculations, and it automatically updates. So it is a reactive thing, and it's really quite nice. Oh look, there's my ducks. There we go, ignore that. That was the video. There we go, here's some code. So here's the code for the hexes. In our server, we just have to define an output, and my output was a text. So all of these are just text boxes, and they come up instantly or naturally as a box. And then in my UI, I've just had to kind of put it in a left sidebar. You'll see there's lots of kind of divs here because this is creating a web app. But the most important thing is to turn it in the styles, is to use these three things here. So we've got a clip path. This polygon is what turns it from a regular rectangle thing into a hexagon. So that's quite helpful. And then I had to make sure that they kind of overlapped, because the top of this box and the bottom of this box, I wanted them to overlap. And then I took every other one, which was the even child, and I shifted it around to kind of make it tessellate. So it took a little bit of playing about with, but that's how you turn regular old boring kind of KPI boxes into a nice little tessellation, which is lovely. and then here was our lovely quacky duck. What we do here is, it's a much easier process now that the documentation has caught up. It's literally plug it in and straight out of the box, it gives you a chat AI assistant. So the user submits a message, the server calls the model, it gets processed, and results render instantly. So for my UI, I just had to set it up so that we had messages on one side, and then on the other side I put in a few action buttons. Those were my kind of automatic go-to question buttons. And then my server, what we do here is you have to grab an API key. So I kind of set that all up. Then we compose the message. So here's my system prompt. So this is me kind of programming the AI assistant. So, oh look, you are Quacky the duck. I did give it a name. Whoops. A playful, quick-witted duck who helps people. Rah, rah, rah. And then at the bottom, we return the system role and then the user role. And I've got 2 user roles there because one of them was the buttons and one of them was the custom input. Over here, that's kind of how we had to work out. I found a little bit of a bother trying to do buttons as well as custom input. If you ignore the buttons and just do a custom input, it's actually much cleaner and easier and simple. However, because I wanted to show off some buttons, I made life a little bit more difficult for myself. So I just had to make sure I put in some async and some wait in, and it all kind of worked out-ish. I also couldn't do custom and buttons. I had to write my custom as a button and then send it over. So if anyone else can figure that out, great, well done you. In the time I had to make this, I didn't have the time to do that. And then last, here's my quick buttons. I just did a reactive event. So once they click it, I had to make sure that it was in the right order and it was able to do things at the same time. So it was clicking the button, sending the thing, the server was reading it, it was responding, and then giving it all back out. So yeah, but the documentation is really nice for Shiny for Python, really clear, really clean and crisp. And as I say, it really does work out of the box, so it's really quite nice. So my issues were, I'm not overly good at async. In fact, until you spoke about it at an event a few months ago, I had not heard of it. So it helps, it really does help, it's brilliant. And then my button and custom chat thing that was a bit annoying. Oh look, I've got some. Shiny for Python is great. AI integration, actually really easy unless you decide to do something weird like I do and always make things difficult for yourself. Oh, you don't need to worry about all this. Shiny is just awesome, blah, blah, blah. Okay, oh, I'll come out of there. That's enough of that. So there you go. There's some Shiny code, Shiny for Python, and I shouldn't end in that. That's how, if you wanted to make your own AI chat box and put it within a Shiny app or a web app of your own, it is definitely doable via Shiny. Cool. So what else happened at Brighton Pi? Let's find out. Not Brighton Pi, that's where we are now, isn't it? Oh, I've been talking too long. What else happened at EARL? So we actually just held EARL last week. Literally last week, we were just kind of rounding everyone up and sending them on their way. It was an absolutely fantastic week. 3 days we had of people. And here are our key themes that came out of it. So our first one was package development, a lot of creating and maintaining R and Python packages for reusable, efficient and collaborative code. And people are really getting into this. They are seeing that it's so useful having these packages already pre-developed and not always having to reinvent the wheel each time. So that was a big push within the industry. We've got a lot of professional collaboration, strengthening meaningful connections to share ideas and insight and expertise is absolutely fantastic to see. There was some talk of AI, I mean there always is these days, but it was really excellent to see that it was all people first AI. It's a tool, it will be a tool, it's not going to come for your jobs because people want to see and talk to and hear from people. You know, we are a society and a species that revels in communication and community and things. So yes, we have all these machine learning models, but we need to prioritize fairness, transparency, and human values. And our keynote, Wes McKinney, who wrote Pandas, that Wes McKinney, was very much in a case of what you should do is learn possibly more now how to read and critique your code. So AI might be writing your code for you, like to speed things up and make it quicker, but you need to be the one who's like reading it and evaluating it and deciding if it's worth moving and using. So that was really good. He thinks we're not going to lose our jobs. It's okay. Let's hope. Lots of transferable skills across different roles, tools, and industries. Nobody really cares what tools you use as long as you're producing the work. And R and Python are gaining a competitive edge through innovative analytics and machine learning. So we're definitely standing above competitors. R and Python are being used more and more in industry, and it really is giving everyone the edge. And code in production, best practice for deploying reliable and scalable data science in real-world environments. So there was a lot of talk about that. So those were our key themes that came out of EARL. We had 42 talks. We had over 200 people in attendance. I think it was at least 120 per day. Oh, 53 speakers. Sorry, I forgot the workshops as well. We had people from all over the globe, minimum 14 industries, and that was only in our talks. Our keynote speakers, we had Rachel Keane, who has the coolest title in the world. I want that job title. Chief Inspirer. Like, it's actually Chief Data Inspirer. So she just like goes out and inspires people. And her first line of her talk was, "I failed maths." And you're like, what? How did you fail maths? And now your job title is Chief Data Inspirer. It was incredible. She's very exciting to listen to. Then we had Eric Drass, who actually popped in earlier just to say hi. He is an artist. Oh, you laugh at that joke. Yeah, he was creating lots of programmable art and AI, using AI to make lots of art. Really crazy and quite out there art, but very impressive. He's very exciting. You should check out him. And Wes McKinney closed the conference. Absolutely amazing man. Has a wealth of experience. He was talking all about his career and all the things he's done. But he started in finance, and he was just working with Excel and going, this is not good enough. And created pandas. Yay! So pandas is my favorite, obviously. But then he went on and talked about all the other projects he's doing. Pandas is kind of left in the dust now, and it's kind of way beyond. But it was stunning to hear from him. He has just announced his talk slides this morning on LinkedIn, which I've reshared. So if you want to read through those slides, check out my LinkedIn. We also had an amazing panel of people who are fractional, what's the word? Fractional directors, I think. So they just pop in and they got to give us a really good overview of how kind of management and data and strategy all kind of work together. So that was very interesting. We also did some workshops on the Tuesday. So if any of this is sounding like it's of interest to you, oh, and a huge lineup of speakers. If any of this sounds like it might be of interest to you and you might want to be involved next year, we will probably be announcing before Christmas applications. So if you want to be in the room next year, if you want to be there, if you want to give a talk, we would love to hear from you. Or if you'd just like to attend, or if you want a keynote sponsor, I don't know, do what you want. Yeah, we'd love to have you there. So all details will be announced when we decide them. So, but it'd be awesome to have you there. Okay, I will try and stop talking for a bit. Have we any announcements from the crowd? Any community announcements? Nope, don't want to be talking. That's fine, I will continue to talk. Our next Pi meetup is actually, as I say, a mashup between Pi and R. It was just going to be kind of a talk on their side, a talk on our side, and then a few drinks and, I don't know, Christmas cheer. But I think we've come up with a better idea. We think we might make it competitive. So I'd love to see us there. Come on, we need the best Python team to see if we can beat the R team. It may not even happen, but in my head, that's what we're doing. Also, if you ever want to have some training in R and Python, we do a lot of that as well, so ask about that. And that is me. Thank you so much for attending tonight. It's been absolutely fantastic to see you. If you would like If you pop over next door to the Joker pub and mention that you're at Brighton Pi, you should get 10%. I'm not sure if I'm allowed to say that online, actually. So I know, yeah, people are not really going to, if they're not in person, they're not going to do it. But still, I don't know if I'm allowed to say. Yeah. We're Jyoti from India. She might pop over next time again. Anyway, thank you ever so much, and good night, everybody.